We are here on the next topic, the logical gates. So this is an important topic for the competitive point of view. You may get the questions in the JEE mains related to this topic. As well, this is a important topic to understand the electronics and the working of the electronics. So a quite interesting topic. So let's dive into it. It's logical gates. As you can see, the symbol, you will find this kind of symbol in these books, or the different kind of. We will discuss all kind of these symbols. You need not to worry about anything, right? So let's first understand what is the logical gate at all, right? So the logical gate is any kind of circuit that is giving us the logical output for the different kind of input. For example, the input is on, then output may be something, let's say on, okay, and if input is off, it means a switch is there can be different input for this switch, on and off. There can be two kind of input, okay. So and the output can be, for a circuit, output can be on and off. So, or let's say there is a bulb, so there can be two situations of the bulb, on and off, right? So a simple kind of circuit we can imagine, if you look in the basic circuits, let's say there is switch beside you. If you on it, then the bulb will become on. If you off it, then bulb will become off. So you can say this is a logical circuit or a logical gate. Here as well I have taken two examples. This is one example just to understand, okay. Although we will not be using these kind of questions, this kind of example in these questions, or the JEE mains will not be asking these kind of questions to you. This is just basics to understand. So here I have taken that there is a battery, and there is a battery and a bulb is connected to the battery, right? And there is the switch connected to it, and there is one resistance. Now input is on, it means this switch is closed, okay. Then tell me what will be the output. Will this bulb, will this glow, or will it become off? When the switch is closed, you know that current will be passing through this, because this is the least resistance path, right? So that's why it will not glow, or you can say it is, the bulb is off. So you can say it's off, and let's denote the off by 0. So let's denote the on by 1. So when the input is 1, it means that the switch is on, then output is 0, right? Now let's take the just opposite input, that is switch is off, or you can say switch is open, and open I am denoting by 0. So then output will be that this bulb, so this bulb will become on, right? Because the current will be passing through this bulb now, right? So that is 1. So when you are giving the input 1, then output is 0. When you are giving the input 0, the output is 1. And this kind of situation will be there for any time. So this is a kind of logical circuit, okay. And the inputs will be only two kinds. One kind of input, you may call it as on, or you may call it as circuit is closed, or you may call it something is live, okay. So these kind of situations we will generally denote by 1. And there are the another kind of inputs which are just opposite of that. So for example, that switch is off, the bulb is off, something is dead. These are denoted by, generally they will be denoted by 0. So in these logical gates, there will be only two kinds of input and outputs, 1 and 0. Nothing in between, like the bulb is glowing or it is less glowing, okay, the glow is not that much, right? So these in between situations will not be there, okay. Now I have taken another example just to understand. what is the input, what is the output. So here I have taken another circuit where there are two switches. Let's call it as switch 1 and switch 2, and there is the only one output. So there are two inputs, and corresponding to these two inputs there is only one output. Okay, switch 1, and I have drawn these different situations, and there are total four different possible situations. When the input 1 is on, it means switch 1 is closed and switch 2 is closed, and you know both of these switches are closed, then this circuit is a closed circuit. That's why this bulb will glow. So let's write down the on by 1. So on, and the bulb is also on, so that is 1. So 1 1, input is 1 and 1, so then output is also 1, right? Now next is this is first is on, so that is 1, second is off, so that is 0. So 1 and 0, and we know that when the second switch is open, so then the current will not flow, so that's why bulb will not glow, so that's why that is 0. Okay, so first circuit, first input 1, second input 0, so then the output is 0. Okay, and if the first input is 0 and the second input is 1, tell me what will be the output? Will this bulb, will it glow or not? It will not glow, right? And that is 0. And 0 0, of course, that is 0. So this is just the input output relation or input output table. So although these are the particular type of operations, this will be called as NOT operation. We will be learning about that, and on the basis of NOT operation there is a gate called as NOT gate. Then there is this second kind of situation. So this is called as the OR operation, and on this basis there will be a OR gate. And let me also draw the third kind of somewhere here. Okay, here I am having some space, so let me draw it. Third. Okay, third. First, second. Okay. Yes, keep it like this. This is the bulb. Again, I must say that my handwriting is not good, so it's just a thing that you need to understand. Yeah. Great. So this is switch 1, switch 2, and this is output, and let's call it as the input 1, input 2. So tell me, input 1, input 2, and the output, different situations. So there will be total 4 possible different situations. So this is on, so both are on, both are off, one is off, second is off, first is on, second is off, and first is off, second is on. Okay, tell me the results from here. The results will be when both are closed, of course the current will be passing and this bulb will glow. So that is 1 1 1. And 0 0, both are open. We know that current will not pass through any of these switches. Okay, so that's why the 0 0 will become 0. Okay, and the next 1 0, 1 and 0, it means 1 is closed and second is open. Still the current can pass through this bulb, that's why that is 0 1. And the second is closed, first is open, still the current is passing through the second, and that's why that is passing through this bulb, and that's why that bulb is glowing. So that is 1. Got it? So this is third kind of operation that will be known as the AND operation. Okay, just let me check it. Oh, sorry, this will be called as this. The third one will be called as the OR operation, and this will be called as the AND operation. The second one will be called as the AND operation, and on this basis there will be the gates, AND gate, OR gate, and NOT gate. Just keep in mind, here I did some mistake. Here it was AND gate and this was OR. Okay. Now let's move. So now this table which we have drawn over here, this will be called as the truth table, where we are drawing the inputs and outputs. So what is the truth table? Truth table is a table that consists of all the possible inputs and corresponding outputs using the binary digits 1 and 0. So these kind of tables will be called as truth tables. And again, this truth table is important and there are many direct questions on this truth table in the JEE Mains. We will be discussing in the coming lectures, no need to worry. Right? Now, see, we are using 1 and 0. So we need to learn how we will be using these operations, how we will be adding. See here, it was 1 and 1. And now the output is also 1 and 1 and 0, the output is 0. We are not able to understand why that is 0. Like let's say 1 multiplied by 1 is 1, okay, or 1 plus 1 is of course 2, right? So it means how we are getting that output, how we can use the plus minus signs and you can calculate that. So for that there are some Boolean postulates and this algebra is called as Boolean algebra. That total there are many things. Just we are learning it for our logical gates. So we will not learn everything about the Boolean algebra. Possibly in some time I will upload the video on the Boolean algebra as well. So let's learn something that is just sufficient for our exam. So we are just discussing the Boolean postulates and laws. So 0 plus a, so something plus 0, it means no input plus some input will be equal to that some input, right? So like 0 plus on will be equals to on, and then 1 multiplied by a will be equal to a, 0 multiplied by a will be 0. All these things, all these kind of operations we will be understanding in these circuits, no need to worry. Just now you need to keep in mind 1 plus a is 1 and a plus a bar, okay, or a complement, that is 1, and a plus a is a. Yes, this thing you need to keep in mind. 1 plus 1, that's why will become 1, right? And a dot a is a and a double bar or complement of a, complement of a is a. And now there are some laws, and these laws you know, some of them you know that you have used for the vectors. So like vectors follow the associative law, so these Boolean algebras also follow the associative law. So a plus b plus c can be written down as a plus b plus c, right? And a dot b dot c can be written down as a dot b dot c, right? And the distributive law, the a dot b plus c can be written down as a dot b plus a dot c. And commutative law, so a plus b can be written down as b plus a, and a dot b can be written down as b dot a. So no such kind of that rule that used to be in the vectors, like a dot b or a cross b cannot be b cross a, but in this case a dot b or the Boolean algebra a dot the Boolean algebra b can be written down as Boolean algebra b dot Boolean algebra a. And there are the important theorem, De Morgan theorem. So De Morgan theorem is a plus b transpose a plus b whole transpose or the complement is equal to the a complement dot b complement, and the reverse of that, that is a dot b complete transpose or the complement, that is a complement plus b complement. So just this much for this lecture. Next we are going to discuss about the logical gates. So we will be discussing all kinds of gate in this next lecture. Okay, and if you want to learn about the other topics, you can watch the playlist on this available on this channel.